Okay, so let us see what we need. Let us try to finish this quickly, because then we'll see the interface, which is not going to be as convenient as we think. By the way, guys, I apologize. Let me publicly, for the record, admit that I'm an old idiot. Sort almost sorted n. I claim it's not a good name for what we do. Why? Why do I say that?
It's not clear whether the last underscore n is bound to almost sorted.
No. No, it's deeper than that. It's deeper than that. You see, we had 3 cases when such a sort should be effective. And the last case was almost sorted. It's all right for small. It's all right for we're putting few things from, but almost sorted, it's going to be really, really bad. Why?
I was thinking we could try to address that by, if there's a block of things that are in order but in the wrong place.
We can address that, but if we take million guys and perturb them, but not by much, this is not going to be a good sort. Why?
Shifting a lot of them.
No. Because in general, insertion sort is good for this case. When we implement main sort, which we'll use, of course, quick sort like structures, what we will realize, this is going to be our last pass, right? But now we're using binary search as an algorithm. We use upper bound n. What does it do? It actually assumes that you have to go far. It does not rely. So I think that the name of this guy is binary insertion sort. We cannot escape. Sort of the peculiarities of what we have cannot escape us. We have to state clearly. Just, I apologize.
But we eventually will make the
Yes, we shall. All of them we will solve. We will know more. You will know more about insertion sorts than you ever wanted to know. So, binary insertion sort n, right? So let us look. Guys, it's just so many hard problems we have to face, even now, before we get to that. Because we have to figure out how we call shift. And we will see a problem here. It's shift back. Maybe shift back by 1. Okay. Or it actually should be shift left by 1.
You're not shifting right.
Because, oh yeah, pardon me, we are shifting right by 1.
I would call it shift by 1. Or shift right by 1.
Shift right by 1. Shift right by 1.
We have a range from insertion point to last.
Suppose comma I.
Last goes to insertion point and everything else moves to the right. There's no first there, right?
No, but it can't be I, because it's from the insertion point to.
It from insertion point to the last.
So I insertion point comma last. Yeah.
Except we just, no, we didn't. We saved last, thank you. And then, what we need to do, to x. So this is sort of delayed swap. If you see what I mean, okay. And then first, I would recommend that we look carefully here and see how we start, where we check, what we do. What?
It should be 0 if
It should be 0 on the first call, right?
Yeah, no. Yes, it should be. Let us ignore this. Let us concentrate on this. Yes.
So does the shift right by one increment the last?
no.
It moves the one before last into last, but it doesn't increment last. That's what increments last. So when we start this thing, we assume that there is a questionable element in last, that we haven't exhausted the thing, right? And how do we know we haven't exhausted the thing? We know it by this, all right? So I strongly suspect that a simple solution, and now we forgot to increment something else. Yes. Otherwise, no. Now, maybe we could do a brave thing. Do we really need to check this? Yes. That, I think, would fix it too. Because then, if n is 0, we're going to do the right thing. Should we test it? We need to implement something. What you're doing? Where do you need to? You could do it right there in line. Well, or whatever. Do it your way. You're right. STD, iterator, tray, whatever. The horrid stuff.
So aren't we doing additional work if n is 1 or less?
One iterator assignment.
Well, we're calling upper bound, we're calling shift, right?
Or if it's exactly 1.
If it's exactly 1, yes. So we could, obviously, if we so desire, just skip a couple of iterations. But this is an optimization. No. Right now, we shall see. We're very far from optimal code. Let us concentrate. Could you put it on to do whatever we have? The ideas list?
In the ideas list, optimize for one element.
Optimize. In some sense, let me put it simply, any sort should be optimized. Whatever algorithm you use, you shouldn't use it for a singleton. Yes, that's my favorite thing. I always throw exceptions. So, for the record, I throw fits, not exceptions. Okay, so, okay. let us try to write shift right by 1. Okay? And observe that we have a top level. I mean, we already know how the top level is going to be. It's going to be shift right by 1, and it's going to be inline. It's going to return void, seemingly. And or should we make it circular shift by 1? Guys, think, because that will simplify this code. You would not need to do this anymore. And then we have a really good name. It's going rotate right by 1.
So
Well,
we already dereferenced last to call upper bound.
What? You need to dereference, so you could write star last here. You didn't need to have X there. And then I'm just trying to look for the most beautiful code possible.
Well, rotate would need to call shift right by 1 anyway.
No. Why would it need? Because I could dispatch. You see, we're going to have a top-level dispatch where we're going to say, are we forward iterator? And if we're forward iterator, we will do this. If we're bidirectional iterator, we're going to do that. Let us quickly sketch a code for bidirectional iterator. So for bidirectional iterator, you literally will just do the backwards one and save, do copy backwards, and for forward iterator, you need to write Perham's algorithm. Like create, save, move, save, move, save, move. Or move, whatever. Yeah. No. Create a temp. Yeah, we can write it in C++. We will write it in C++. So, you remember, it's going to be, yes, it's going to be tag. std forward iterator tag. So bidirectional iterator tag. But we need both. We need both versions. And the top level, so you need this with forward.
Now we really start to miss concepts here.
Yeah. This stuff is dreadful. And then we write inline thing, which does the dispatch. Well, that's how everything is done right now, so we should do what? No. Yes, pardon me. And then you say shift right by 1, I first last, and now you have to write the horrid stuff. std colon iterator traits colon angle I angle colon iterator category open paren close paren. Beautiful stuff. One should. But the good thing that it generates no instructions. This is the code which generates no instructions.
Yeah, but it still requires the type tag to be a concrete type.
It requires a type. Well, this is how it's done now. Yes. So I'm not advocating. Look, I have been proposing concepts, for the record, for at least 20 years. Maybe in about 5 years they will exist. I'll not be programming in 5 years. So even now when I work on them, I'm working, it's like an old person planting an apple tree. He knows he's not going to eat from it, but still does that. None of this work I'm going to see. So
Bidirectional, we just call that is.
yes, so let's implement it for bidirectional because it's really simple. We still need to save. Here we do. Let us save last. Here we have to decide whether it goes from last on from probably we need to go last minus 1. That's tough. Because do we make it the same interface as every other STL function? Or not? Past the end. Now it should be. Let us slide down. Let's slide down. It's not bad because what we will do, we'll say plus plus last, and that will observe. This goes, this goes.
But that doesn't
No,
work.
but then that doesn't work
No,
because
you
we
need the X to do the upper bound.
Doesn't
we
work
need to
for
be able to do
forward
star
iterators.
last.
What? Not here, not at this point. Not at this point. We no longer need to do. Well, yeah. Even if we do rotate always uses more stuff than.
Well, if you want to pass past the end,
Are we consistent with the use of first level?
Everywhere else. Okay, let us look. We get rid of this. This becomes star last. Then we get rid of this. We get rid of this, and we might even put this. Whatever, we could keep it like that. No. This is, yes, it's rotate, yes. Yes, thank you.
Do we need last plus plus? Instead of plus plus last.
Where? No, that is the whole point.
I mean, we need to increment last in this loop somewhere.
Except you will see, it's going to be, sadly enough, it's not going to work. You will see in a second. Where am I assigning? Well, we actually do not even need this line. We could write this call in there, if you so desire. This is fine, yes.
It's fine. It just means the forward iterator version will get to the last item at the very end, and then has to put it in the front. So you have to save first.
Yeah.
uh,
Not a big deal.
hey,
Yes. Okay, so let us do it for bidirectional iterator. It's called copy underscore backward. And it is we need to say first, last minus whatever, predecessor of last. No, it's first predecessor. Could somebody look up the interface to copy backwards? It's obviously not. It's first. So it needs to go, we're shifting We're shifting there, so we need to have, it should be predecessor of last, first, predecessor of last, last. Am I correct, Nick? Yeah. It's first, last, and then the new last. The end of the destination. Yeah.
Why is new first not last minus 1?
Because sadly enough, there's this thing called iterators, and neither bidirectional nor forward iterators allow you to write minus 1. This is this thing called STL. You might consider looking. No, we need to get a value. Thank you. Yes, yes, of course. Of new first. It's going to be first. It's the norm. It's the normal range. First predecessor of last, however we get the predecessor. Or let us define it for people who do not know. Just right here. No. What is this? We don't need last. Or say but last. Call it but last. But last. It's perfectly good in English. One but last. No, not but. But. B-U-T. But underscore last. Or you could call pred last. Or whatever. But last. Yeah. No. Star X has to go into star X you get from first. No, not from first. Yeah. But last. Stars. Yes, thank you. That's correct. I'm right, left, it's all the same to me, guys. No, you cannot dereference it. We changed, yes. So this we implemented successfully. And it's going to do n+1 assignments. No, it isn't backward. Yeah, but our result is last. The end of the result is last. We're moving. Yes. Just think. Let us draw. Pictures are good. Everybody agrees pictures are good? Let us see what we're doing. We have, where was the thing? Let us look. We have first. We have last. He is not there. But last points to this guy, right? So what we do, we take the range first up to but last, range F, B, and shift it by 1.
But the docs here say copies elements in the range first, comma, last.
Yeah. Yes?
No, not but last. Last. Open. Okay.
Yes, but our but last is
And into the range terminating at result.
exactly.
But the point is it should be first plus 1 is what
Ryan,
No.
we're moving F to B.
We're moving first. We're taking elements. Okay, let's take elements. 1, 2, 3. We need to move 1 and 2. So our first is 1. Our last is 3. Not past 3.
Talking about overriding 3.
We are overwriting 3.
But I'm telling you what the copy backward documentation says.
Yes?
It says that you give it first, last, and
First,
the
last.
end of the where the result is going to start.
The end.
No, it should be
No.
first plus plus.
Look, somebody, go and look at the,
code right now. It's while last is not equal to first.
yes?
It's going to insert into result.
But it decrements result right away. It's pre-decrement. It's pre-decrement. I wrote the code. It is pre-decremented. Okay? Okay, thank you. Thank you. We'll find out if it works, but it does. These are normal ranges. The whole STL is constructed in semi-open ranges everywhere. There's no exceptions. This is semi-open range. Yes, now
Is that, doesn't seem like that's the right value for X.
we need to save but last, yes, and then we store it there. How else?
Could you scroll up so I can see how this thing's getting called from, so we'll scroll down
Scroll down.
so that we can see how that's getting called from
So
there.
we pre-increment last to past the end,
Okay.
and then we back it up to the left.
Told you it's hard stuff, guys. Now, but this is where really hard stuff starts. Okay. Who goes? We save first. No matter what we need to do, we save first. But it's trickier than that in some sense. We actually now do not need to save first. We need to save pointed to first. You need to save the, not the value. Let us look at this, by the way, but last. No, here we could do nothing like that. What you're doing is good and right. Or maybe it's old first. Or you want to do current and keep first. Yeah, this is good. Yes. Yeah, let's call it current. Cur is a swear word. You cur. This is tricky, guys. No, 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 you cannot do plus plus current. We could, yeah, at some point, but not at the first point. Because you still need current to move. Yes, save the value. We have to. Because if you go there, especially inside the loop, in first time around, say, oh, I'll use first. But that's no, he needs the value. No, actually, he doesn't need the value. He actually doesn't need the value. You don't need the value. You need the value of the other guy. And that's why maybe your original idea was correct, but incomplete. To do plus plus current, but except you need to save its value outside the loop. You need the previous, yeah, but here we're trying to find a way where we sort of get the previous element from the previous iteration, as it were.
So just say start current equal to previous element. We fix up the start up later.
No. We're moving that way. We're moving to the right. You have to go from current to the next, not to the previous. Next. Yes. That's the tricky part.
So start previous equal to start current. And
Are we
then
using current and next or current and previous? What are our two names for iterators?
Current is the one that we're going to put into the next space, right?
Okay, so
So-
current and next.
So star,
Save the next one.
save the next one, which is current at that point. Or save the one in the first space, which is at that point.
Wait,
see wherever we are, we have to assign it to the previous position, right? Because at every position, we have to take the value and move it one place back. So what is the one place back? You make sure it's previous. Just say start previous is equal to start current.
pictures.
Yeah.
Why don't you repeat that?
I think.
Who is the spoon?
We'll talk.
All right.
Yes. We can. Actually, literally can use STD rotate. With one little difficulty, but we can. We have to and maybe they'll end up doing that. STD rotate is defined, of course, for
Rotate in the first place, and you said no, can't do that. I said this earlier when we were talking about this.
what I probably meant. I do not remember the context, that at least in bidirectional case, you clearly do not want to use rotate. You don't want to do 3 reverses, which it will do in bidirectional case. 3 reverses, we will study rotate one of these days. It is the most efficient for bidirectional iterators. We will get to that. We'll get to that. Well, I mean, let's not do rotate today. I promise we will study rotate. It's very important. No, how could it possibly work, guys? How could it possibly work? You see what? You have to go from previous to current. And if you do it like that, a tragic thing will happen. We're going forward. You're moving 1 to 2, 2 to 3, 3 to the place of 1. You can reverse line 20, but there will be difficulty there.
So we do need a copy of the value, right?
Yeah.
And the problem is that you have to write from that copy. You have to do a swap between what you saved before.
You have to save the next spot and then move something into it.
We could actually
You might as well use swap, yes, because you will be effectively swapping, yes. Or you could do 2 assignments, whatever. Told you it's going to be hard. When you want to surrender, I have the code. But well, the pictures are very simple. This is the picture. You know. This has to go here, this has to go here, and this has to go here. Yes, temporal thing gets lost in that kind of picture, because what you need to do, if it's the old value in this location, because if you move there, you overwrite 2. Yes?
swap.
And
So
two- you
Two
take
goes
the
to
previous
temporary
value
value,
and
swap the
assign,
1 and
right?
2, and then do the whole thing. That's swap.
Okay, guys, temporarily, we are losing completely. So let us try to do the following thing. Let's use Vitaly's suggestion, who is absolutely correct. We can, while we do not want to write rotate here, since we could do better, why don't we at least temporarily, till you guys figure out either, I want to try something before the end of the class. So why don't we use std rotate here? That still requires some difficulty.
Okay, I will hand over back to Ryan, who can do that. I was still in the middle of it, so this is all myself.
Okay? So does anybody understand how it will work if we use std rotate? Okay? Let me just remind you that std rotate does literally, if you give it 3 points, first, middle, last, it will in place exchange ranges from first to middle and from middle to last. So what do we need? We need to have a range from first to but last. This is the first range. And the second range is from but last to last. It's 1 element range. So we could use that, and there is a beautiful algorithm which we'll study eventually. Right now we'll just use it. Except we cannot call it here, because we lost but last. We have to change the interface. Shucks. Let us look. No, forward iterator, just, we need that. Everything. Let us look at the point of call. You see, what if we look here, what would be terribly nice if we could have insertion point, last, and successor of last. Yeah, but last and last. Well, then that is, yes, it might work once. No, you never do that. We have successor at this point, I thought. We defined successor, no? Didn't we? In algorithms, which we include. Stand last plus plus. And then we have to go and fix, by the way, our version for. Right? Then, by the way, it's really dreadful. You know, when we're done, we'll see that we don't have to do that. This is a temporary thing because we're slow. First, but last. It's as simple as that. Of course, this silly guy is going to do a dispatch on category. Yeah, no, it's all eliminated. It's all gone. You don't need to. And did you fix, and we need to fix bidirectional case. Okay, guys, let us write little main, which will take an array of these. We need to include whatever you got. Where did you get? No. You also need to include iterator. Where did you get? Upper bound n. And you copied it in this directory? Okay, and let's just go and try to sort an array, C array with 7 elements. Like 1, 2, okay. 1, 3, 2, 4, whatever, just scramble them, whichever way. Yeah, something. Yes. Since we have 3 minutes, we have to. Okay, and you really have some ambitious people. Now we need to nail this rotate word. We don't want really to write that. We don't really want to pass 2 arguments. Two. Whatever, I mean, it doesn't matter. What, 5 is good. Then, and we have a thing called print all, which will print them. So say print all these guys, and then it's an algorithm, a grep. Yeah. I think it's an algorithm. I forgot. Grep, what? Print range, yeah. So print nums plus 5. We're going to go like. And sort, whatever it's called. Binary insertion sort n, I think. And therefore it has to be nums 5. No, just 5. And then we need to say the line 8. And it will not compile because we put so many bugs. Do we need standard less? It needs standard less, thank you, therefore it needs functional. Binary insertion sort needs less of int. No. No, we did not write the one without. So pass it. It's std less angle. No, it's right here. Std less of int, or like that. And repeat line 10, line 8. And now close your eyes. Include functional. No, no, it's not going to compile. No. 3 errors. Let us go to the top. You don't want to look at, because it's look at the first error. File. So successor, don't we have successor in algorithms? So we did not include successor. Go and include algorithms in the insertion sort. Yes. Yes. 2 errors. What is this? Let us look at the. Yes, thank you. Thank you. Did you say that? No. That. How not passing? We're passing it right here. No, but that's. But we're not complaining. We're complaining about rotate by 1, which. No, it's 3 arguments. 3 arguments. Let us go and see how we call it. Last successor, we call it with 3 arguments. Thank you. Thank you. Yes. Renaming functions has to be done. This is why Emacs is the superior editor. I have to choose him.
Like iterator category.
It's not called.
It is called iterator category. Okay, which is it? Okay, include, because we need to include iterator in that file.
Do you need type name before that whole expression?
Yes, you do, of course, of course, of course, of course, of course. Yes, thank you. Pretty amazing. At least we have something. We succeeded in our initial try. We haven't, of course, got anywhere close. No, that's how programming is. Param was depressed. He hoped to finish it today. Okay, I strongly recommend that you guys try to work, but since not everybody will, we will finish it. So I think that rotate by 1 is a very useful thing, will serve us well, should be included in the library, but needs to be done appropriately. I think calling rotate is a temporary measure, because it's going to use a complicated Grist-Mills algorithm for rotating. It's very beautiful, but unnecessary in this case. Yeah.